Hey everyone, thank you all for joining us this afternoon for this webinar on version control in Unreal Engine. I'm Matthew Doyle, your host. I just want to remind everyone in the chat that if you maximize your browser, you'll get a better viewing experience. And you can also use the Control plus and minus keys to scale up the webinar. So once again, thanks for being here. We'll be getting started in about 5 minutes, and we'll see you then. Hey everybody, just another quick reminder before we get started. We'll be starting in about a minute. I'm Matthew, your host. The webinar will start soon, but if you'd like to maximize your browser now, you'll get a better viewing experience. So we'll see you in about a minute. Hello, everyone, and welcome to this webinar for Unreal Engine on source control or version control, if you prefer, inside of the Unreal Engine. My name is Matthew Doyle, and I will be your host for the day. The first thing we'll do today is look at a brief explanation of what version control is and how it can benefit your workflow. Then we'll look at the 4 options that we have available to us inside of Unreal, and those include Perforce, Git, Subversion, and Plastic SCM. We'll go over the pros and cons of each option, and we'll look at the basic setup and usage inside of the Unreal Editor. Version or source control is essentially just a way for you to store different versions of your files. In fact, you can store versions of your files going all the way back to when you first created your project. You can even add new files to the version control, remove files from the version control, and while you can use version control by yourself, it works great for collaborating with a team. Now, the simplest form of version control is to use something like Dropbox, or simply to use your local hard drive to store different versions of your project. But these options are not very robust or scalable. In a professional environment, you're going to want to use a professional source control management or SCM tool. Professional version control tools are going to allow you to track the changes of your file or keep a history of those changes. And those changes are going to include who changed the file, what was changed, when the file was changed, and why it was changed. Generally, the way it works is you will merge your changes that you make on your local computer into a master source of truth. And this is probably going to be a remote repository containing all of the changes ever made, as well as the current state of the project. And if there are ever any problems, the good thing about source control or version control is that you can roll back the changes to any previous version. You can roll back the entire project, or you can roll back just specific files. We have 4 options available to us in Unreal Engine for version control. Those options include Git, Perforce, Subversion, and Plastic SCM. Plastic SCM being the newest addition. The first option we're going to look at today is Git. Let's first talk about some of the pros and cons of using Git. In the Pro category, Git is a decentralized or distributed version control system. What this means is that every user will download a local copy or create a local repository of the remote. Because of this, it's incredibly fast. All the operations the user would do are done locally. So adding files to the repository and committing those files, all of that is done locally in their local repository. Now, this is also a bit of a con, because as each user has their own local copy of the repository, as a team size gets larger and larger, you may run into conflicts when trying to merge all those changes back in to the remote or master repository. Another issue is that there is no checkout or locking system with Git, especially for binary assets such as bitmaps, images, and UAsset files. Fortunately, Git does support binary files using LFS inside of Unreal Engine or the large file system. But unlike some of its competitors such as Perforce or Plastic SCM, the large file system support still needs a little tweaking. Fortunately, Git is open source and completely free to use. But if you're not going to be setting up your own Git server, you will need to pay for one online. However, you could also use something like GitHub, which is free to teams and provides both private and public repos. While setting up your own Git server is not really that complicated, still using Git for both client and server can be kind of difficult if you're not an engineer. And that's because most of working with Git is done from a command prompt or terminal. However, using Git provides very flexible workflows. You can work in a lot of different ways to manage your version control pipeline. And it includes a very robust branching and merging system, as well as being able to stage files that you've added or changed before committing them to the branch. If you're going to be using GitHub, you might want to download GitHub Desktop. You'll find it at desktop.github.com. And what GitHub Desktop is going to give you is the ability to use a GUI to send your files back and forth from your local repository to the GitHub repository, making it a lot easier. So once you've downloaded and installed Git on your system, the first thing we need to do is set the username and email address that we'll be using to mark our check-ins, our commits to the repository. That way everybody knows who did the check-in. To do this, we need to launch a command prompt. And from here, we're going to type git config global user.name, and then in quotes your full name or whatever you'd like to use. After that, we also need to set the email with git config global user.email, and then again in quotes the email address that you'd like to use. We can jump back into Unreal now, and inside of our project we'll click on the source control button at the top, and then we'll click connect to source control. Using the provider dropdown in the login window, we need to select Git. Now in the source control login window, the first option we have here is Git path, and that simply points to your Git installation. You shouldn't need to change this. After this, we have the root of the repository. So this is our local repository. Should be the same as the project folder's location. And from here we have username and email, both of these set from within Git itself using the terminal. Now keep in mind that username and email, these are not your login information for your remote repository. This is simply when you commit changes to the repository. This will simply let people know who made the changes when they're submitted. After this, we have the URL of our remote server, or the origin, and I'm going to paste that in here from GitHub. We want to make sure that we use a git ignore file, so we'll leave that checked. Then we have a basic README file. If we'd like to create one, I'll go ahead and do that now. And let's just change this to source control webinar. We also want to enable add a Git attributes file. This will allow us to use the large file system for Git, which will allow us to upload images, binary files like UAsset files, and so forth. After this, we can include an initial comment for our initial commit. I'm just going to leave it at the default of initial commit, and then we need to initialize our project with Git. We can see on the bottom here that it's adding files to the local repository. We'll go ahead and give it a few seconds to finish. Alright, so once that's finished, we can click the Accept Settings button. With that done, we can see our source control button at the top here now has a little icon, a green one with arrows letting us know that we are currently using source control. Let's have a quick look at the project structure now. Inside our Unreal project, we can see we now have a .git folder, as well as a .git attributes file and a .git ignore file. The Git folder is going to contain everything you need for storing branches and commits, all the changes and things you'll be doing. We really don't ever need to mess with what's in here. If we open Git attributes, we can see that this is where we're specifying which files and folders will be set up to work with the large file system. And in this case, basically anything inside the content folder will work with the LFS system. And this will include all of your UAsset files, images, and whatnot. Opening Git ignore, this allows us to tell Git when we're checking in changes, when we're committing to the repository, to ignore these files and folders. So the first ones here are folders. So we have binaries, derived data cache, intermediate, and saved. We don't want to check any of those into our repository. And then all of these here are going to be file types. So anything with these file types as the extension, we don't want to check in. Obviously, if you did want to check some of these in, you'd need to delete them from this file. And of course, you can add other file types and folders here as well. From here, we need to send our entire project to our remote repository. And we could begin to work in here and add files and make changes and alter things in our project, but anything we do here is going to be checked into just the local repository. The remote repository will serve as our source of truth. It will always contain the version of our project that we want everyone to have access to. The quickest way to send our project to our remote repository is to use the git bash. It's basically a terminal or command prompt. We can right-click in the project folder, and as long as you have Git installed on your computer, you can select Git bash here from this menu. And this will bring up the Git bash window. Let's look at some of the commands that we can do in here for Git. First of all, if we type git status, this is going to tell us what the current status of our local repository is. And as we can see, we have an untracked file here. That's going to be our thumbnail, data prep PNG. Now, if we want to add this to the staging area, we would simply type git add and then the file name. Or if we want to add everything that needs to be tracked, we'd simply use a period. Now, if we do another status, we can see that we no longer have any untracked files, but we do have some files that need to be committed. Again, in this case, our thumbnail. To commit the file to our local repository, now remember, we're not sending this to the remote. We're sending this currently to our local. We'll type git commit, and then we'll use the M switch to send a comment, and in the comment we'll type something like initial commit and hit enter. And we can see the commit was successful. If we do a status now, we should see that we have no commits needed. Okay, so these are some of the very basic options we have at the command prompt for working with Git. But what we want to really do here is send our local repository over to our remote repository on whatever server we're using, and in this case that's going to be GitHub. And if we want to see where our server is located, we can always, remember, type git remote and then -v, and we can see there that we are pushing to the origin, which is located at GitHub. So from here we'll type git push -u. We're going to push to the origin at GitHub, and we're going to push the master branch. And from here we simply need to let it run and finish uploading the files. This can obviously take some time depending on the size of your project. Alright, and once it finishes, you should have no error messages, and this will let us know that our local repository has been pushed to our remote repository, again in this case GitHub. Returning to our repository in GitHub, we can clearly see that the project structure has been uploaded, including the config, content, and source directories, as well as our Git attributes and Git ignore files, our project file, our thumbnail, and our README. And you can see the README here has the change that we made inside of Unreal when we did our initial commit. So from this point, obviously, I'm not going to go into detail on how to use GitHub itself. Feel free to look into the GitHub documentation if you'd like to learn more about using it. But let's look at a second way to send our files to GitHub. Another way to send our files to the remote repository is to use a GUI for Git. And there are quite a few of them, including a Tortoise Git GUI, as well as SourceTree. But in this case, we're going to be using the GitHub desktop app, and it's quite easy to use. We simply first need to add our repository, so we'll go to the top left, click the Add, Create, or Clone Repository button here. And we have three options. Again, we can either clone the repository, and this allows us to clone a repository from our GitHub repository list. We can also create a new repository, and finally we can add a current local repository. So that's what we're going to use. We'll click on Browse and browse to the location of our local repository. And then we simply need to click the Add Repository button. And once this is all set up, we can see we have our initial commit, just as we set up in Git inside of Unreal's editor, and all of the 277 files that will be committed to our remote repository. But before we do that, let's go to the settings on the top right here and select repository settings and just verify some of this information. Of course, we have our git ignore here, just like we have in the project folder. From here, we have our remote. I've set up a second GitHub repository, and our git LFS file is also incorporated. So now we're ready to go ahead and push this to our GitHub repository. To do that, we'll hit the Publish button. Now that we're all set up, let's briefly look at how we can make some changes and then submit them to GitHub using Git inside of the Unreal Editor. First of all, I'm going to make some quick changes to some assets in the map here. I'm going to select these render helpers, and I'm going to change them to movable. This will, of course, require a save of the map, so let's go ahead and do that. And once I do that, you can see that the file is now checked out. It has a little red check mark to indicate that. Now remember, when working with Git, we don't have actual checkout options per se, so this is not really indicating the file is locked. It's just letting you know that it's ready to be added to the repository. Now I'll go into my Datasmith folder here and materials, and I'm going to take this lamp base file here, and we'll go ahead and open that up. I want to set it up so that I can use a material instance. And for that, I'm simply going to add the ability to multiply this texture map by a base color. So we'll add a multiply node here. Then we'll add a 3 vector here, plug that into the B slot. Let's go ahead and make the default value here white. And we'll plug that into base color. And we'll convert this to a parameter and call it base color. Okay, now let's save that. And you can see after I've saved it, I also have this now checked out. Likewise, if I right-click this and create a new material instance, let's call this mi_base lamp base. This new material instance has a yellow question mark, and this is letting us know that it is not actually saved to our repository. So let's go ahead and save it to our local repository by right-clicking, going to Source Control, and marking it for Add. It now has a red plus to let us know that it has been marked for add. In other words, it's been put into the staging area of our local repository. We simply need to commit it now. Now I can right-click on any of these assets, go to Source Control, and choose Check In. Or I can go up to the Source Control button and choose to submit everything to Source Control. This will bring up the Submit Files window, and because I chose 3 files at the same time, I'll be checking them all in at the same time. So for this change list, we made minor map tweak, and we adjusted the material and created an instance. Let's go ahead and hit submit. And we can see that our changes have been committed. Of course, these commits were only made to our local repository, the local copy of the project. So in order to send this over to our server at GitHub, where our source of truth is to be located, we'll need to now push that to the server. Now remember, there are 2 ways we can do that. The first way is to open a git bash in the project folder, and then type git push origin master. And this will push the branch that we're working with to the original source, which is the GitHub project. Alternatively, we can go into our GUI app here for GitHub, and we can see we've got our new commit ready to go. So we'll go ahead and hit sync. And now back in our repo on GitHub, we can see we now have 3 commits. So I'll click on that there, and we can see our new commit for our map tweak. Let's go ahead and click on that. And it shows us exactly what we did. We created a new file, mi lamp base uasset. We modified the lamp base material, and we made a tweak to the map. Okay, so that's the basic setup and operation of using Git with Unreal Engine. Rather than continue showing you how to check out and push different file types in this Git project, we'll look at Perforce next, and we'll spend a little more time on that process once we get it all set up. And we'll even look at how to submit C++ classes, as well as how to work with blueprints and how to diff those when we talk about Perforce. Now let's look at some of the pros and cons when using Perforce. Now keep in mind that these are mostly the high-level pros and cons. So every user is going to find different reasons why they like and don't like a certain tool. But these are the ones that stand out to me the most. First of all, for Perforce, the pros include being able to lock or check out files, which is something you can't really do with Git. And this is really good for avoiding conflicts. So you check out a file, and that lets other users know that someone else is currently working on it. Now that doesn't mean that if a file is checked out, another user can't make changes to the version on their computer. It just means that they can't check those changes back into Perforce because someone else is currently working on the file. It's simply a flag letting people know that someone's working on it. Another good thing about Perforce is that you can also use it to include the engine source. So if you're doing special modifications to the engine source code, you can do that with Perforce. And Perforce has a very easy to use visual GUI and several tools that make things easier when it comes to diffing files and so forth. Perforce is considered industry standard. It's very scalable. It works well in enterprise situations. And it also handles large files like images and uasset files very well. Perforce is actually free if you're a small team, up to 5 users with 5 workstations. But from there, it can scale up and become kind of expensive, especially if you're running a server. Servers can become very costly. And some might consider the fact that Perforce is a proprietary tool. It's not open source like Git. Now, because Perforce uses a centralized server for the source of truth for your project, it can be slow at times. Whereas when you're working with, say, Git, every change you make, every commit to your local repository is done locally and very quickly. Instead, with Perforce, every file needs to be sent back to the master server as you work with those files. But overall, Perforce is highly performant. Perforce does have a branching system. It's called streaming, I believe, but the system is not quite as robust as the one you get when using Git. All right, so let's jump into Unreal and look at how to use Perforce. By default, when you launch Perforce, you're going to have the Open Connection dialog window pop up, and this is where you're going to put in the server address as well as the username on the server, and then finally your workspace. Perforce's concept of workspaces is really just the local space on your computer where you'll be downloading the repo files from the server. And this is where you'll do all of your work and then submit the changes that you make back up to the server. Of course, when you first start using Perforce, you're not going to have a workspace, so be sure to click the New button to create a new one. And once you have all this information properly filled in, we simply need to hit OK to begin. Once the Perforce Visual App, or P4V, has launched, you'll find a Depot tab and a Workspace tab. The Depot tab is going to be the files stored on the remote server. The Workspace tab is all the files on your local computer. If you want to download everything from the Depot, you simply need to go to the Depot tab, select the folder you'd like to begin downloading, and hit Get Latest. And this will pull down everything inside that folder. Now, before we begin to send our files to the server from our workspace, we need to copy our Unreal project into our workspace. Let's look at how to do that. Now, the first thing we'll need to do in order to work with Perforce is to make sure that the project we're working with exists inside of our workspace. So here I am in my workspace folder. I'm going to go into this a little bit deeper, into my collaboration folder here, and I'm simply going to paste the project here. And now that it's in my workspace, I'll be able to send this over to the server back in Perforce. Let's go ahead and launch the project now. And now from here we'll go to Source Control, connect to Source Control, and then under Provider we'll choose Perforce. So the second field here is for our server address, including the port number. After this is going to be the username, and then we'll need our workspace. Now if you don't know what your workspace is, as long as this file exists within the workspace, if you use the Available Workspaces drop-down, it should automatically find the workspace. And now we can hit Accept Settings. And we can see that our connection to Source Control was successful. Now you're going to notice that because we haven't sent any of these files to the server yet, everything is marked with a question mark. So for instance, if I go into my Blueprints folder, that's also marked with a question mark. My props are all marked with question marks, my materials, and so forth. And it may take some time for these question marks to appear as everything gets connected up. So this just means that we haven't done our initial commit to the server. So inside the Perforce client, now that we've copied our project to our workspace, if we click on the Workspace tab, we should find it in that same location. So there it is, sure enough, under Collaboration, Data Prep 4.25. So the next step we're going to need to do is to send our project over to the server. So to do that, we'll simply select the project folder and then click the Add button to add this to a change list. From here, we'll choose a new change list. And for the change list description, we'll type initial commit, and then we can hit OK. So now if we go to the Pending Change List tab, and then we select the change list for the initial commit, if we open that up, we'll see all of the different files for our Unreal project ready to submit to the server. Of course, there are some things that you will not want to check into Source Control, such as the intermediate and saved folders. So what you'll want to do is, in your change list, scroll down until you find those folders. Select the first one, scroll down to the bottom, and hold Shift and select the last one. With all of the different files selected within those folders, we can right-click and revert. In the Revert Files window, simply click the Revert button. This will ensure that we're not uploading the intermediate and saved folders to the server. Alternatively, you can let Perforce know to ignore certain file types as well as folders. To do that, we're going to go inside of our workspace copy of our project here, right-click and create a new text file, and we'll call this p4ignore.txt. Inside of this file, we can add folders, so for instance, intermediate and saved, as well as file types. So maybe I don't want anything that ends with solution, so I would put star.sln. Now I simply need to hit the submit button. And assuming I don't want to make any changes, I can now hit the submit button in the Submit Change List window. Now, if you get a pop-up window giving you a warning about not being able to submit from a non-stream client, there are some things that we can check. It's possible the depot on the server is a stream depot, and our workspace is non-stream. So if we go ahead and close this down, and then we can go to Connection, and then edit our current workspace, we can see that the stream field is empty. So let's go ahead and click Browse, and locate the stream that we want to use. In this case, it's going to be Dev Enterprise, and then hit OK. So the stream system inside of Perforce is essentially the branching and merging tool. But there is quite a bit more to how the stream system works inside of Perforce. I'm not going to go into detail on that, but I encourage you to check out streams in the Perforce documentation to learn more about it. All right, so now that we have set up our streams properly in our workspace settings, we're ready to submit our files to our Perforce server. So we'll go back to our pending change list here again, right-click and choose Submit. Or, of course, if we have it selected, we'll just hit the Submit button at the top here. Once again, we have our Submit Change List window, nothing to change here, and we'll hit Submit. And if there are no further errors, you'll get the Submit Change List Progress window, and now we just have to wait for all those files to be uploaded to the server. So let's make some changes in our project here and see how we can send those changes to the server when we're finished and look at the locking mechanisms and so forth. And we'll start with some basic asset changes. I'm going to select one of these lamps in the background here, and then I'm going to browse for the material asset. So if we open up that material asset, that's going to be M lamp base here, we can see we have our material graph. What I want to do is I want to create a material instance out of this that I can make changes to. So first of all, let's go ahead and add a scalar parameter to our metallic value, and we'll call it metallic. And let's also set it so we can adjust the base color by multiplying this texture. So for that, we'll need a 3 vector, and we can plug that into base color. And let's convert that also to a parameter. We'll call it base color and set the default to white. Okay, we can save our material now. And you can see that when we do that, we are asked if we want to check out the asset or simply make it writable. Now keep in mind that if the file is already checked out by someone else, their username will be listed here under checked out by, and the checked out selected button here will be grayed out, so you won't be able to check this out. So I'll go ahead and check out the asset. You can see now that I've closed my material window that I have a little red check mark on that material. And this is letting me know that that asset is currently checked out by me. So now to check our material into our Perforce server, we'll right-click on it, go to Source Control, and choose Check In. We'll need to enter a change list description. So for this, I'm going to say Added Parameters for Instance, and then hit Submit. And we'll right-click and choose Create Material Instance. And I'm going to call this mi_lamp base. Upon creating our material instance, not only will we have this save icon in the bottom left, it should also now have an icon in the top right, which is a question mark or a yellow question mark, and that's letting us know that this file has not been checked in to our version control system yet. To do that, we can right-click, select Source Control, and then select Mark for Add. Now that we've done that, we get a red plus icon letting us know that this asset is ready to be checked in to source control. Let's make some changes to it first. So we'll go into base color and adjust that value. And finally, we'll set the metallic value. Okay, let's go ahead and check that in using right-click, source control, check in. In our Submit Files window, we need our change list description. So I'm going to just simply write initial commit, and we'll hit submit. Now back in Perforce, I can go into the depot, open my content folder, and locate the material that I just checked in. And you can clearly see from selecting it here, the UAsset file has 2 of 2. And this means there are 2 versions, and we're on the second version right now. If we want to see the change list, we need to go to View, Submitted Change Lists. On the Submitted tab, other than the initial commit, you can see the second change, Added Parameters for Instance. And if we open that up, we can see the material file, the UAsset file there, that we changed. Now, I can roll back my changes by going into Perforce here, right-clicking on this lamp material, and choosing Get Revision. The total number of revisions is 2, and we're on number 2, so we'll go ahead, specify the revision that we want, and that's going to be revision number 1, and hit Get Revision. Keep in mind you won't be able to do this while the Unreal project is open. Now back in Unreal, our material has an exclamation point over it, and this exclamation point is letting us know that we do not have the latest version from the server. So if we right click and go to source control, we can click on history, and this is going to show us the different commits that we've made to the Perforce server. So we have our initial commit, and then we have our added parameters for material instance. We can even select this by right-clicking and then diff this against the previous revision. And this will bring up our diff window from Perforce. Here's the previous revision, and here is our current revision, letting us know that in a current revision on the server, we have added some parameters. So let's go ahead and right-click on our material again, go to Source Control, and we'll sync. And this ensures that we have the latest revision. So if we open the material up now, we have the changes we made in revision 2. Working with blueprints and version control is basically the same as working with other assets. Let's go ahead and open up this shell blueprint here. All I have it doing right now is printing out hello, but let's add a collision volume and set it up so that when the player walks into it, a light turns on. So the first thing we'll need to do, of course, is add our collision component, and we'll add a light. From here, inside of our event graph, we'll go ahead and select our box collision, and then we'll add an on overlap, and we'll bring in our light. We'll pull off of that, and let's set the color. And let's make the color something really strange here, like green, just for demonstration purposes. And we'll go ahead and compile and save. And of course, when we save, we get our Checkout Assets window again. We'll make sure to click Checkout Selected. And let's go ahead and submit this to the server. So now let's look at how we can diff blueprints when we have multiple versions of those blueprints. Let's go ahead and reopen our blueprint here. And let's select our collision box again, and we'll add an end overlap event, and we'll set our light color again. And this time we'll change it to red. All right, and we'll compile and save. And once again, we'll need to check it out. And let's go ahead and submit it by checking it in. All right, so now that we've made some changes, let's do some diffing of those changes. We'll right-click on the asset, and under Source Control, go to History. And then we have our different changes here. Let's start with the second revision. If we right-click that and then diff against the previous revision, which was our initial commit, we get our blueprint diff window here. So here on the left, this is going to be all of the different things that could have been changed. And if they are yellow, that means something has changed from the previous version. So for instance, if I open up my blueprint, we can see that variable point light and variable box were added. So originally we didn't have a collision box or a point light in it, but they were added in this revision. And if you look to the right here, you can see the changes. So here's the original revision under components. You can see all we had was a default scene route. And on the second one here, we now have a point light and box collision. Likewise, if we go under components, we can see that we added the box collision node, and then we also added the point light node. And then finally, if we open up the event graph, we can see here all of the things that we did inside our event graph. So first of all, we added our point light variable. Then we added a set light color. And then finally, we added our on begin overlap. Now we can move around. Let's go ahead and make this bigger here. We can move around by panning, right-click and dragging, just like we can in a blueprint graph here. And you can see the difference between the blueprints. If we want to change that, we can unlock it so that now only this side is moving or this side. But let's go ahead and lock those in place again. All right, so that's a good way to look at the differences of your blueprints in between revisions. So in my content browser here, I'm going to right-click and create a new C++ class. And we'll make it an actor class. Let's go ahead and change the name of the actor here to Webinar Actor. And we'll create the class. Now that our C++ actor class has been created, there are a couple of ways that we can get it onto our Perforce server. First of all, we can use a Visual Studio Perforce plugin. All right, so to check this in, we're going to click Add to Source Control, Helix Core, and we'll need to put in our information here. And now we can hit OK. To specify the change list, we're going to choose New, and we'll write Initial Commit. The other option is, of course, to simply load up our client for Perforce, select our source directory as well as our solution file. We'll mark it for Add. We'll create a new change list, and again, we'll call this Initial Commit. Then on our pending change lists, we'll select our new change list, right-click, and submit. Of course, checking out, working with, and then checking back in C++ classes works the same way as all the other assets. And just like the other assets, you can use the diff tool to see the differences between the various revisions of your classes. All right, so I think that's all the time we have to cover Perforce. We've done a pretty good deep dive into how to set it up and use it inside of Unreal Engine for version control, as well as looking at the P4V tool. Up next, let's take a look briefly at how to use Subversion. Okay, so before we begin to talk about using Subversion and how to set it up, there are some basic pros and cons we should cover. Again, these are high-level pros and cons that most people would agree with, but your mileage may vary. Every user is going to have different opinions. First of all, in the pros section, Subversion is once again an open source tool. It's provided by Apache. It is free, and it's very easy to use and very easy to set up. And there are some great GUIs to use with it as well, including Tortoise SVN. And it has some good conflict resolution and some other features. However, it does keep a second local copy of your project, what's called a working directory, and this can basically double the file size on your local hard drive when you're working with SVN. And it does have limited merging capabilities. It has some issues there and some low performance, and it doesn't scale very well for very large teams. Also, many users have complained that history lookups can be slow. And finally, if you prefer a distributed version control system like Git, keep in mind that Subversion is another centralized option. Okay, so we're going to look at how to actually set up a Subversion server, and there are a lot of ways that you can go about doing that. But in this case, we're going to be using a NAS on my local network. Now, if you're using a NAS like I am here, you'll need to install SVN. The Synology NAS has an SVN package. You'll just have to do a search for it here and install it from here. Once installed, we can open the SVN server, and we need to create a new repository by clicking the Add button, and we'll give the repository a name. And from here, we also need to add users. I'll go ahead and add myself, and then we can hit OK. And now we've created the repository on our NAS. This is where our remote version of the project will be stored. If you open this back up, take note of the access URL. We need to go ahead and select and copy this. This is how we'll access the remote repository. In addition to installing the SVN package on your NAS, you'll also want to get the client. A good one to use is Tortoise SVN. Simply go to tortoisesvn.net/downloads.html and then download either the 32-bit or 64-bit version depending on your version of Windows. Now, in order to import our current project into SVN, we'll go ahead and select that project, right-click on it, and we'll go to Tortoise SVN. You should have Tortoise SVN and SVN Checkout in your right-click menu if you've installed Tortoise SVN. From here, we'll click on Import. We need to make sure that the URL of our repository matches the repository from the NAS. And now we can click OK. We'll be asked for our username and password here. And now it begins to import all of the files from our local project into the SVN repository on the NAS. Now that our project is stored on the NAS, the next step we need to take is to create a working copy directory of the project. This is one of the cons of using Subversion. It essentially keeps 2 copies of the project on your hard drive. Let's go ahead and close down our import window. To create a local copy, we'll simply right-click in the folder where we'd like to store it, and then choose SVN Checkout. Again, for the URL of our repository, we want to make sure that this matches up to the location of the repository on the NAS. And then we want to set up our checkout directory. So this is going to be the location of our working copy. And from here we can simply hit OK to begin downloading. With our working copy created, we'll simply enter that project folder and launch the project. Now in our project, of course, we'll go to our source control button and select Connect to Source Control. For our provider, we'll select Subversion. Into the repository field, we'll paste our NAS Subversion address and we'll put in our username. For the labels directory, we're going to enter tags. This has to do with tagging C++ files. So unless you're working in a multi-user team environment that does a lot of C++ programming, you probably don't need to worry about this. You don't have to enter the password here. It will ask you for it when checking files in. However, I'm going to go ahead and put it in so that it never asks for it again. And we'll hit accept. And as you can see, we have a green light on our source control letting us know that we're connected up to Subversion. Let's briefly take a look at some of the right menu options available to us for Subversion here inside of our working copy directory. If I create a new text file, for example, let's just call this deleteme.txt, and then right click on that, go to Tortoise SVN, I can now add this file to my Subversion repository. Or I can add it to the ignore list. Let's go ahead and do that. Likewise, if I click on a file that's already in Subversion and then go to Tortoise SVN, I have a lot more options available here. I have some diffing options. I can easily update to a specific revision. I can rename, delete, and lock, and work with branching from here. Back in Unreal, working with Subversion works the same way it does with all of the other options. So we'll go ahead and select our render helpers here, and we'll set them to static. And we can see we have one file that needs to be checked out. Let's click that, check out. And the file that needs to be checked out in this case is going to be the map. So let's go ahead and check it out. And now if we go into our maps folder, we can see that not only does the map need to be saved, but it does have a checkout indicator. So we can go ahead and save that file and then check it in. And of course we'll need to set our change list description. As with the other options, we can now right-click the map, go to Source Control, and then History, and this will show us the different check-ins that we've done. And here is our second revision, which says Made Spheres Static. Now, if we go to our project folder and then locate the asset that we just changed, we can right-click on that map, go to Tortoise SVN, and then show the log. And in the log here, we can clearly see our second revision, Made Sphere Static. Now right-clicking on the asset again, I'm going to go back to Tortoise SVN, and this time I'll use the repo browser. This brings up a browser window that's pointed to the remote repo on the NAS. And you can see that that asset clearly has 2 revisions there as well. So you can clearly see that using SVN or Subversion is actually very easy. It's very easy to set up a server, very easy to use with Unreal. So obviously we covered most of the file check-in process when we talked about Git and Perforce. So rather than continue to show you how to check in files for Subversion, let's go ahead and move on to our final topic for the day, and that's going to be Plastic SCM. So let's talk briefly about some of the pros and cons for Plastic SCM. You may notice there are a lot of pros, but not a lot of cons. And the reason for this is that Plastic SCM is a relatively new source control system. So I think a lot of people are still figuring out what those cons might be. But I'm happy to hear what any of you watching this webinar today might have to offer in the cons section for Plastic SCM. As far as pros go, Plastic SCM is very flexible. It offers both a distributed as well as centralized model. And you can even work in a mixed environment of the two. Now, Plastic SCM can be expensive, and this might be considered a con, but there are free versions available as well. You can use Plastic SCM locally or on the cloud, and they also have enterprise options. Plastic SCM comes with a lot of great built-in tools and a built-in GUI. It actually has 2 versions of the GUI. One is built for programmers, and the other, Gluon, is best for artists. It has a very robust branching and merging system, and it can even be used to diff images and preview those images. Okay, so let's go ahead and look up how to install and use Plastic SCM. To download Plastic SCM, you'll need to go to plasticscm.com/download. From here, we have several options, including a free personal or community edition. And then under Commercial, we have Cloud, Team, and Enterprise editions. In this case, we'll be using the Team edition. Keep in mind that all of these editions have a cost. When installing Plastic SCM on Windows, you're going to have two options for GUIs. You can either use the Plastic SCM GUI, and that GUI is best for programming, or you can use Gluon, which is better for artists in game development. I'm going to go ahead and select Plastic Gluon. When you install the Plastic SCM server for Windows, you can choose to launch the console, and when you do, you'll need to enter a password for your administrator. And then we can click Finish Installation. Once in the console for Plastic, you'll have access to all of the settings for your server, as well as authentication for your users, the repository storage system, where those files will be located, and a lot more. You'll also have a monitor option where you can monitor the performance of Plastic. In the Plastic SCM configuration window, we'll need to specify our server location. We can easily do this since we're working locally on our Windows PC by clicking Scan Network. And here's my server. I'll go ahead and hit OK. Next, we'll need to configure our credentials. That's going to be our username and password. And then we can choose a repository. If we click Choose, we can select the default repository. But in this case, I'm going to create a new one. And we'll call this Webinar Plastic SCM. Now we need to select our working directory or workspace similar to Perforce. So for that, we're going to click the Choose button and browse to our Unreal project. And now we can hit Apply. We have access to our workspace here, and this is our entire Unreal project. We can also click on Check-in Changes, and this will allow us to submit any changes we've made. You'll notice that all of these files are currently marked private. And this is because they haven't been submitted yet to our version control server. Let's go ahead and do that now. Now, before we check things in, there are some files that I'd like to ignore. And those are going to be the saved and intermediate folders. So for that, we simply need to locate those folders and select them all. With all the folders selected, we can right-click and choose Hide Ignore, Add to Ignored List. And we can use either the name of the item or the full path. Now, to set up my initial commit, I'm simply going to select all of the items. And then in the comment field here, I'll type initial commit. And then we can click Check In. You can see that Plastic SCM is very fast on the check-in here. Of course, we are working locally. And now if I go to Change Sets, we can see our initial commit has been added. If you don't see that commit, be sure to hit the refresh button. Okay, so inside of our working directory for Plastic in our Unreal project, we need to go to Source Control, connect to Source Control, and then for Provider, we'll select Plastic SCM. Everything here is pretty much already filled out for us, so all we really need to do here is click the Accept Settings button. And of course, we have a green light on Source Control. So let's go ahead and make a quick change. Let's go into Materials and open our Chrome sphere. And here, let's simply change the color. And save. And this will bring up the Checkout Assets window. And we'll make sure the material is selected and click Checkout Selected. And now we can see in the editor window here that the material now has a red check mark, letting us know that it's ready to be committed to the Plastic SCM server. So we'll go ahead and right click, go to Source Control, and check in. And just like that, we've done our first commit with Plastic. Now back in Plastic Gluon, if we go to Change Sets and hit Refresh, we'll see we have our new change made material black. We can now see that under Content, we have two change sets. We can open that up, go to our Materials, and we can see that mChrome Sphere UAsset is where the second change set occurred. And of course, in Unreal, we can go to Source Control on the asset, click on History, and see those same changes. We can right-click and then diff against the previous revision, and this will show us that the new version has the RGB color changed to black, whereas the old version was white. Alright, so that's going to do it for Plastic SCM. We're basically out of time today. It's just a very high-level walkthrough of this tool, but I hope it's enough to get you started if you'd like to start using it. And remember, checking file types out for materials and textures and C++ classes and blueprints are all going to work basically the same from version control option to option, including Git, Perforce, Subversion, and Plastic SCM. Okay, so if you'd like to get some additional help on using version control inside of Unreal Engine, I have some links here for you. and I'll try to leave this up long enough for you to write them down. First of all, we have the Unreal Educator live stream. This one they did on Twitch, and they did a great job presenting some of the options available to you, and did a detailed dive into using Perforce. There's just more of a deep dive video where they talk about a lot of the different options, a little more than I did. So definitely check out that live stream. It's about 2 hours total. Then we also have Unreal Version Control Fundamentals. This one was from the beginning of the year in 2020. And again, it's about a 2-hour long video on our YouTube channel, the Unreal Engine YouTube channel. And again, they go into considerable detail on using version control in Unreal, including with Perforce. And believe in this one, they even go through setting up a Perforce server. Finally, we have the Unreal Engine documentation using source control there. You'll find that in the Unreal documentation link available on the screen. Otherwise, simply go to docs.unrealengine.com and then search for source control. And not only do they have a page on using source control, but they have some sub-pages, one for Perforce and one for Subversion currently. You can also check out unrealengine.com/online learning, and there's a lot of great free learning there available for you. There are over 70 courses available in 4 different languages. They're all video-based. You can win badges and points as you go through the different courses, and they include interactive assessments. I have several courses on there. There are courses for architectural design, for games, for all the different industries, and courses covering everything from getting started in Unreal all the way up to advanced topics. Okay, so thank you all for being here today. And they include interactive assessments. So let's go ahead and open it up to Q&A. There are courses for architectural design, and once again, I want to thank everybody for being present. And courses covering. And I hope you enjoyed the webinar and was able to pick some stuff up on version control. I should have Daryl Obert with me here today also to help me answer questions. Daryl, are you there?
I am, yes. As long as we're, yeah, good stuff. Thank you, Matt. That was really, really lovely presentation. Nice high-level overview of a variety of options. So I think that should definitely get people excited about putting source control into their workflow if they haven't been using it. And of course, you've provided some links for some further learning.
Yep. All right. So
we had
any questions we got?
There's a few in here. So several people are asking, which ones are you using, and what do you personally prefer? Which ones?
So my favorites are obviously Perforce because of the professional scalability of it. It's basically industry standard in games, and that's my background. That's where I came from. I used Perforce for a very long time in games. And then my second favorite is Git. I use Git for my personal use, like I do modding and stuff for games, and I'll upload. I do a lot of open source coding that I'll upload to GitHub actually, and I do that with Git. Git is a little complicated to learn, but once you get it down, it's a pretty good tool. But I'm starting to really like Plastic SCM. I haven't had a lot of use with it yet, but it seems incredibly robust. It has a lot of great features in it. And so I'm really starting to like that one too.
Yeah, and the fact that it has the ability to work either centralized or decentralized kind of makes it gives you a lot of flexibility there for that. So another question, was asked about with Perforce, is there a way to, or I'm sorry, with Git, is there a way to like manage locking and unlocking of files a bit more? And I know that there are some options for that, so maybe you could expand on that.
Not built into it, but there are some plugins and stuff that you can get. I believe Git extensions is one of them, and also in the Unreal Marketplace, there's an actual Git plugin for the Unreal Editor that I believe adds locking and stuff like that. So there are some options out there. You just have to look for them.
Another one was which Git or SVN for speed. And I know that Git with large binary files historically could be a little slow, but maybe you could expand on that a bit.
Yeah, well, I mean, Git is fast. The only reason why Git is fast, I say, is because everything is done locally, right? So like imagine with SVN or Perforce, you're doing all these changes. You're working on a file. You touch a blueprint. You touch a material. And then when you're done, you submit it back to the master server, right? And that's because you want other people to be able to access those same assets and do whatever they need to do to them, right? Well, with Git, you're working locally. Everything you do on your local copy of the repository, you just do it all there. You work with all the files, and you don't just keep checking those files back in to the remote repository, but instead you're using your own branch essentially, and then you'll merge that branch back into, say, the master branch or whatever branch you want to merge it into, and everyone else will merge all of their branches back in, and then there will be, conflict resolution and all that kind of stuff going on. So it's fast because generally the workflow involves working locally. But of course, uploading files to a remote server, especially large files, yes, it can really start to slow down, and especially with large teams. If you're working with large teams, it really starts to slow things down and can cause a lot of conflicts.
Yeah, the upload to the server, we're all working remotely, and we use Perforce at Epic. So I'm sharing project files with Matt, and of course my project files are going to have ridiculous light maps in them, and big 2K reflection captures and massive EXR files. So those levels they can get slow to upload and download. So one thing that I've been trying to do is to separate out my lighting level and kind of utilize level streaming to help manage that process, so that if I'm not constantly rebaking the lighting or constantly, changing anything that's in the reflection captures, to have that stuff living in a separate level, so that then if I do move objects or add lights or do some other things on my main working level, I'm not, constantly shoving up a map that's 2 gigabytes or something like that. Cause my upload speed's good, but that hurts you.
Yeah.
For sure. So there was a couple questions it came up in both sessions that we did about NAS. So it's an acronym, Network Attached Storage. It's basically a small Linux computer with a disk array attached to it. And a lot of them have the ability to run, because it is essentially a Linux machine, native applications on it. So that's basically what Matt was showing with his NAS. We both have Synology NASs, and there's a variety of apps that you can run on, but that's what NAS is referring to for people who didn't see it in the chat.
Yeah, and just keep in mind, everyone, this was a very high level overview. There's so much more to this topic. There's so many other tools that we could have shown, and assets and workflows, and we just obviously didn't have the time today. I would have liked to gotten into more advanced topics, such as going into branching and things like that, but we just, obviously the webinar would have been 3 hours long. So
yeah, it's a very broad topic, but those links that you provided, I know I did watch the one that Tom Shannon did on the education Twitch stream, and they spent a bit of time talking about setting up servers and things like that. There's a lot of strategies that get into the IT space when you start thinking about, do I throw a server on AWS? I saw some people asking about storage and archiving to get it onto cheap storage. So it quickly grows beyond just how do you use this with our application conversation, and turns into a IT strategy conversation. But Tom did dive a bit deeper into that in his, so make sure you check that out if you want to dive deeper.
Quick question from I want to grab this one last question from Bricktone here about Perforce and images. Yes, it stores 2 different files if you have 2 different versions. It doesn't just store the changes of the image. Now that would be cool, but I don't know how you would be able to merge that back in with some sort of alphaing or something. But yeah, it stores 2 completely separate versions of the image.
Cool. Well, that's about it for time, unless there's anything else that you want to jump in there, Matt. We're getting to the top of the hour, and I'd like to thank everybody for taking the time to spend it with us during this webinar. It was a great topic, and I'm glad Matt dove into it. I know it was a good bit of work, man. I appreciate it.
Yeah, no problem. I enjoyed doing it. It was definitely a lot of work. It's a lot of things to cover, but yeah, I'm glad to have done it, and I hope everyone enjoyed what they heard and were able to learn something.
Yeah, so go check out Unreal 5 if you guys haven't seen any of the videos that we threw up. That came up at 11 o'clock today. So
mind blowing.
It's time to move on and go check out that stuff. It's super inspirational. So we will be here. We'll be doing webinars as often as we possibly can. I know that we've got a few of them lined up. No dates locked down yet, but we try to hit them, every at least once a month. So We will be sending emails out to you all. And of course, this video will be recorded and put to YouTube. So if you didn't catch everything, because again, there was a ton of information in there, you'll be able to go back and watch the YouTube stream or the YouTube replay of it. And Annie will be sending links out to everyone that registered. So that's about it for today. Thank you again, everyone.
Yeah, thanks, everyone. Bye.
Cheers.